Good morning, grade 9s. Okay, we're going to start section 7.2, scale diagrams and reductions. So the last 2 days we've been working on enlargements. We're going to do the reverse of that, which is reduction. So the last 2 days we've been talking about enlargements, and we know that the scale factor of an enlargement has to be greater than 1. So it makes sense that the scale factor of a reduction is going to be less than 1. So we're still going to use exactly the same steps though. When we figure out scale factor, we go scale over original, just like so, right? Scale over original, and you'll know you do it properly when you get a scale factor that is less than 1. So here's the first example, and you can see that I've called this the original, and you can see clearly that this one got smaller, and that's what a reduction means. A reduction means that it's smaller. So remember, we've talked about checking corresponding sides. So if I wanted to find the scale factor of these two figures, these two diagrams, then I would pick a corresponding side. So it doesn't matter which one you pick as long as you make sure that you make them corresponding. So if I went from A to F, the corresponding side is G to L. Scale factor is scale over original. So I can simply count them here. I don't have to use a ruler for this one. 1, 2, 3, 4. Okay, so that's the original. So let's make sure we put that on the bottom. And then the scale is 1, 2. So here's our situation, and you can write it one of two ways. You can write it as 1/2, or you can write it as 5/10. Those are both the same thing, but we can clearly see we did this properly because we got something that is less than 1. So if you mixed yourself up and you put the 4 over the 2, when you got 4 divided by 2, you'd have 2, and you'd realize to yourself, wow, that scale factor sounds like it's an enlargement, which is exactly what it would have been. Okay, so another thing we can do here, and I'm just going to set you up, and you can try this on your own if you want, because I sort of needed a protractor and I can't seem to find one in my house. So how you do this is you'd measure the length of each of these sides, and they're not really very accurate. So if you slap down a ruler here, we're going to try and do this together. I measured that this side here was around 36 millimeters. I'm going to use millimeters in this, and so I should be able to tell you that that's exactly the same at the bottom, that is 36 millimeters. And the side here is also 36 millimeters. And then when I measured these other sides here, okay, I'm just going to show you real quick. I got 12 millimeters. This one was also 12 millimeters. This piece here measured out to be 24 millimeters. And this one here was also 24 millimeters. And this one here was 12. Okay. So I'm going to send these to you and you can print them out, but I just want to get you set up here, okay? We're going to draw this scale diagram with a scale factor of 25/100ths. You can see that that is smaller than 1, so we are going to be drawing a reduction. It is going to be smaller than this original. So how you start this out is you multiply these measurements by the scale factor of 25/100ths, and then you're going to get your new dimensions. And what I usually do is I write them down in a different color if I'm doing them over here. So if you take 36 millimeters and you divide it by, or you multiply it by 25/100ths, you're going to get 9 millimeters. And then you can just quickly, you don't have to multiply all of them because you know that this one also will be 9 millimeters, and this one will be 9 millimeters. And now you can move on to the next ones. So if we took our 12 millimeters and we multiplied it by 25/100ths, we're going to get 3 millimeters. This one's also going to be 3 millimeters. This one's going to be 3 millimeters. And then the two 24 millimeters are going to work out to be 6 millimeters each. So I always take the time and I figure out all my dimensions, and then I'll go over here and I'll draw them, okay? Okay, let's move on to the next 7 notes here. Okay. Scale factor can also be represented like this, and that's like 1 to 25, which is really 1 over 25. And we all know that a line in a fraction means to divide, which could also be represented as a fraction, which is 4/100ths. Okay, so these three things all mean the same thing. And after we're working on our reduction section, on Monday we're going to take a break and we're going to do a mini lesson. We're going to do rate, ratio, and proportion. I just think it's an important thing. It'll get you prepared for Math 10 and also Foundations 20. So we're going to take a break on Monday and Tuesday and just do a little bit of a mini lesson. Okay, so let's get back to these notes here. The Mona Lisa has approximately, oh, that's my assistant today, Hank. Okay. He's probably going to come over. He's very excited about scale factor. The Mona Lisa has approximate dimensions, which are 75 centimeters by 55 centimeters. And it says, if we reduce this painting by a scale factor of 1 to 15, what are the dimensions of the reduction to the nearest hundredth of a centimeter? So we're going to go to the 2 decimal places. So in my mind, I go like this. I don't want to work with fractions, so I'm going to do the 1 divided by 15, and I'm going to get that that's 6/10 repeating, but we're going to round to the nearest hundredth because that's what we're going to be working with. So that's our scale factor. No units, remember, okay? And we know that that is a reduction, that we've done that properly because that's less than 1. So now we're going to take our original dimensions, our 75 centimeters, and we're going to multiply them by our scale factor. And we should get 4 and 9/10 repeating. So I'm going to actually round to 5, but it asked us to go to the hundredth, so I'm going to put 2 zeros in there. So our new reduction is going to have a length of 5 centimeters, and then its width is going to be 55 centimeters times that scale factor again, and we're going to get around 3 and 67/100ths of a centimeter. So there's our new dimensions. Those would be our dimensions of a reduction to the nearest hundredth of a centimeter. Okay, so here we go. We have a regular rectangular auditorium, has dimensions of the length of 22 meters and a width of 14 meters. Represent the auditorium with a scale drawing of 1 to 400. Label your drawing in centimeters. So this is where that metric system review really came into play. We cannot be doing things in 2 different units. So what I would always do is I would take the time to turn these into the same units as what I'm going to end up with at the end, how I have to draw it. So if we drew our metric system real quick here again, our conversion chart, there's our meters, and then it's deci followed by centi, and that's where I can stop, even though I know milli comes next. So if I were to take these meters and turn them into centimeters, I'm going to move my decimal over 2 places to the right. So that 22 meters becomes 2200 centimeters, and my 14 meters becomes 1400 centimeters, and that's what I'd prefer to work with. You could do it at the end if you want. You could reverse it and turn it back into centimeters when you're all finished, but I like to work with this way. Okay, so how are we going to draw our scale diagram? How are we going to figure out our dimensions? Well, what we're going to do is we're going to take that original measurement, the 2200 centimeters, and we're going to multiply it by our scale factor, okay, which is 1 over 400, which as a decimal works out to be 25/10,000. So when I do that, okay, so I get rid of this, I work with decimals here. 2200 centimeters times 25/10,000ths works out to be around 5.5 centimeters. So that's my new measurement. And then I take my 1400 centimeters and I'm going to multiply it again by that same scale factor. And that is a very tiny scale factor, but we have to think we're starting off with a big auditorium, 22 meters, right? So that's quite a large area, and so it makes sense that we're going to have to draw a scale factor, use a scale factor that's very tiny. So when we work out the 1400, we're going to get that it's around 3.5 centimeters. So then you go over here and you take your ruler, okay? And I'm working one-handed here, but I would start probably with my length and 5.5 centimeters. I draw my line all the way here to 5.5, and then I do my width, and you could just quickly draw it on there. Okay. So that was just a quick review of reductions, and when you're given a scale factor, how do you know if it's an enlargement or a reduction? Well, an enlargement is going to be greater than 1, and a reduction is going to be less than 1. So that's how you know, and that's a really important skill to hang on to and concept to hang on to. Okay, these are old notes, so I'm not sure if this is going to be the assignment that I hand out to you. In fact, your 7.2 notes that I post on Google Classroom will look a little bit different. Okay, hang in there, and let's not forget that tomorrow is going to be Green and Orange Day.